Good morrow, fellow humans. My name is Sean Crowley and I am obsessed with infinity. So join me as I attempt to unpick the infinities of what is.
In our chapters thus far, we have found a universe of unimaginable scale with no foreseeable ends at either extent of our perceptual reach. Equally with an unfathomable age, again recognised as having no foreseeable ends. We have thrown around the concept of infinity and tried to visualise what it might mean for us, set as we are, within our own finite perspective. The hope so far is just that we might have begun to stir the pot of intrigue. But ongoing, it's hoped that this intrigue will build towards an unyielding zeal for the questions that hide behind answers, building a skeptic's instinct for questioning the presupposed, so that when faced with dog-eared riddles like, why are we here, we will know to firstly clarify the seemingly obvious, i.e., what is meant by why, we, and here. Within the preceding chapters, we temporarily exchanged our why for how, and spent some time discussing the here. So let's shift our focus once again and try to understand the selves that shape the collective we. Who or what is the perspective holder we are trying to identify? And where does it fit into our picture of reality? If we return to our first assumptions, we each believe that we are alive. Alive within a physical body that gives rise to consciousness and thus a sense of self. But which came first? The body or the life? We may have actually heard questions of this nature before. Which came first? The egg! As one declares so confidently. Obviously it's the egg. I mean, dinosaurs came from eggs, didn't they? Next question. And of course, if we are to contain our thinking strictly to the words offered within the posit, then such confidence is hard to deny. Eggs came before chickens, just as life presumes a body. But maybe such an arrogant dismissal is a little unfair, since at the heart of this ancient philosophical inquiry lies a ponder that is far more complex. But what is it asking? Again, that will depend on what is meant by the relevant presupposed concepts, in this case, our chicken and egg. Because in counter to the position just offered, if we instead assume that the egg in the posit referred expressly to chicken eggs, well then we find the question framed totally anew. Because the answer now comes down to whether a chicken egg is primarily that which is laid by a chicken or that which contains a chicken. Since now we can argue that through the lens of evolution, the first chicken was parented by two birds whose DNA differed slightly from their offspring, the final mutation of the genus Gallus and the first class-specific jungle fowl. In other words, the answer will be egg if the egg is that from which the first chicken emerged, or chicken if the first chicken egg was instead this individual's maiden lay. But as it shows, it's more often got to do with how we choose to label things. As said, this is an ancient question. And so it's really only when we consider it through the eyes of an ancient scholar, unaffected by the labyrinths of biological classification, that the subtext becomes clear. When Aristotle stated there could not have been a first egg to give a beginning to birds, or there would have been a first bird which gave a beginning to eggs, there was no understanding of DNA, evolution, or prehistoric life. But more to the point, none of these newly acquired insights have resolved the underlying conundrum. They just kick the can further down the line. And so it's with this in mind that we can start to appreciate the thread that's being tugged at here. The answer that Aristotle gave himself was that the chain of events is infinite, with no beginning to speak of. Christian theologians who followed gave their answers with an air of arrogant confidence equal to our own, citing the story of Genesis and the beginning of the world. God created the first chicken, not from an egg, but out of nothing. And since the follow-up question, who created God, was forbidden, there was no further need to deal with uncomfortable paradoxes. At its heart, what came first is an inquiry into the living and the non-living universe. What came first? The life of the chicken or the apparently dead matter of the egg? And I am aware that it could be argued that eggs aren't technically dead due to their cells being alive, but Aristotle didn't know that, so we just need to be delicate with our interpretation. After the discovery of evolution, it became increasingly clear that this binary pairing of chicken and egg was actually a continuum that continued unbroken towards the birth of life on Earth, thus substituting what came first with the less friendly, how did life emerge from a dead universe? A question that remains unanswered to this day. Life begins with a cell. These simplest of entities draw upon energy, and with this they multiply. A success equated to the existence of life itself. Today, cellular organisms comprise the entirety of Earth's global biomass, though only 13% are non-plant. Single-celled organisms contribute the next most significant portion, with a 70 gigaton biomass that dwarfs the 2 gigaton collective of all animals. By current estimates, the human body is made of around 37 trillion cells, of which 57% are primarily non-human microbes, which means that 57% of our bodies are technically not human. What we consider our cells are first and foremost those of other cellular beings. But if our own inner matter is made up of life living upon life, what about the elements that make up these simplest of life forms? At what point does inanimate matter become living matter? What came first? Today, there are two families of cells we recognise as living, prokaryotes and eukaryotes. The more complex eukaryotes subdivide into the four kingdoms of protist, fungi, plants and animals, to which we contribute the most meagre of parts. The eukaryotes first appeared in the fossil records 2.7 billion years ago, about 1.3 billion years after the formation of the Earth. But it's the simpler of the two cell families, the prokaryotes, who are the true original inhabitants of the planet, showing up only a few million years after the formation of the Earth. But submerged within the microbiome lies the apparent boundary between these living and non-living units of matter. Unlike its more complex cousin, the prokaryote cell might not have any membrane-bound organelles or nucleus-protecting membranes, but they do have a wall which they use to protect their DNA and protein-forming RNA. But unlike animals, fungi or plants, cells have no living innards. The hard-working DNA, RNA and proteins are just considered chemically active. But are the lines that easily drawn? The only requirement we place on the category of life is that it must A. require energy, B. replicate, and C. change in response to stimuli. But this is just how we describe the cell. What we have done is use the cell to define a boundary, and as such, created it. However, there seems to be no significant shift from the realm of DNA to the realm of the cell, at least not in terms of material. No magical essence gets added to the cosmos once life is present, only new relationships and emergent behaviours. And so what we find is that our description of life is only that, a description, a conceptual boundary used to enable visualisation and communication. But there was no unique catalyst, and definitely not one we would wish to attribute consciousness to. That conceptual boundary is hypothesised much higher in the food chain. And so rather than a light bulb moment, what we find is a dimmer switch, an analogue fading from the lifeless into living. Such was the case with our own emergence, as a single, non-conscious cell became 2, then 4, 8, and so on, whilst our mind's slow, quiet awakening shifted ever further into the light. An eternal flux, ever shifting, ever changing in time, never beginning in a moment. But though we may have failed to locate the objective life-defining boundary between cell and its parts, isn't there still some real objective divide between the lifeless state of the early universe and the life that followed? Surely something ticked. Though we might not fully understand how early Earth's elements combined to form the first building blocks of life, we do have a suite of experiments that have been pointing us in a clear direction for many decades, towards a world where dark skies and black oceans were interrupted only by the stab of lightning and the glow of hydrothermal vents. Because it is here, where seawater meets magma, that the carbon-based molecules were once urged to combine, forming the nucleic acids and organic compounds that are the building blocks of life. In 1952, chemist Stanley Miller performed a founding experiment that intended to imitate the environments of the early Earth. By simply subjecting simple elements to oxygen-depleted environments and then striking them with bolts of electricity, Miller began churning out bands of organic compounds. Tests have since needed reinvention as we have come to learn more about the early Earth, though Miller's beacon still stands as a helpful waypoint on the path to a greater understanding. But even so, the thinking is still the same as it was before. All these experiments seek are the coming into focus of new relationships, not new types. Whether organic compounds amid environments or chickens amid eggs, nothing seems set apart from the whole. So perhaps we should try to restate the question from a different angle. What about what came first, colour or the eye? Does this differ that much from the initial quandary? Well, to find that out, we must again dissect the question into its various presupposed concepts and ask, what is an eye and what is colour? According to the fossil record, the eye emerged sometime during the Cambrian explosion, a period of major experimentation in life's history dating to around 541 million years ago. The earliest and simplest of eyes would have been little more than eye spots, sensitive cells that use photoreceptor proteins to identify the presence of heightened electromagnetic radiation. And it's thought that the ability to detect colour evolved soon after. Okay, so what about colour? Well, thanks to Newton, we understand that colour is actually an attribute of light, and thanks to Maxwell, we also know that light is a vibration of the electromagnetic field. The electromagnetic field is, for us, omnipresent, in and of our every being and place. However, it is only between the play of 380 and 740 nanometers that we can appreciate these oscillating ripples as light and colour. So which came first, colour or the eye? Obviously, the electromagnetic field existed long before the first eye did, so colour wins, yeah? But then, that unique range of 380 to 740 nanometers. It had no special uniqueness before the arrival of sight. So, though the fields of vibrating energies may have been present, was the uniqueness that we attribute to colour anywhere present within the universe? Because once again, colour is not a thing unto itself. It's a relationship. A relationship between the energies of the universe and the knowing of consciousness. Because without this relationship, there is no redness of red or blueness of blue, or any brightness of light for that matter. So, does the eye win then? The first eyes saw no variation of colour, only dark and light patches. Well, that settles it. The eye wins. But then again, the first seen light must have still needed to inhabit some part of the visible light spectrum. All that colour is was still that which was being seen. It's just that it wasn't being subjectively divided into hues yet. White light is just the combination of all colours on the spectrum, so saying that a monochromatic shift in brightness is colourless is equal to saying that real colour is only the colour that we humans perceive. To our eyes, violet is a colour, but ultraviolet isn't. Though for a lion, ultraviolet is a perfectly respectable colour. It's just that red's not. The point is that our particular brand of colour only appeared when our particular brand of eyes and brains did. So, it was a tie then? We could say that, but for this to be considered factually true, a very stringent border of identity must be forced upon the puzzle pieces. Again, just as it was with the chicken and egg, it comes down to how we label things. So as long as an eye defines the visible light spectrum, and the visible light spectrum defines the eye, neither can pre-exist the other. But there's more to this thought, because when colour and eye emerged alongside one another, neither's fundamental state of being changed. When the waving electromagnetic energies were first seen, they never went through any state of change. But nor did the cellular arrangement of the eye. The genes and protein-coupled receptors found in eyes today were already present, only repurposed for their role in vision. Physically, each thing pre-existed its categorical description. And so there was no single spark of a moment, no single tick of a clock that this new relationship can be attributed to. Even the involvement of consciousness appears to precede the activity of sight, quite possibly by generations, since these organisms would have been reacting to the energies of electromagnetism in the form of heat long before the evolution of sight. What we have to remember is that the eye, as we know it, is not an independent phenomenon in the universe. An eye is only an eye when it is linked to a nervous system that can see. This means that it takes the mind to divide sight from warmth, meaning for some time in our history, heat and light would have been experienced via the one sense. Only as entities began to divide their environment into more curious and severe traits of uniqueness did our world's subjective qualities blossom. Until we no longer had to wander amid a wash of homogeneous electromagnetic radiation, as we were now found, discovered in a reality hidden in the merest sliver of frequencies. But if not a physical switch, what then gives birth to the relationship? What goes from being absent in the universe to being present? By ignoring the vast majority of its environment, consciousness has tricked itself into seeing itself. By ignoring the vast majority of its environment, we now think of ourselves and all other phenomena as that which are separate. So whether we talk of colours, eyes, chickens, eggs, life or lifelessness, It's never the collecting of information that causes relationships to emerge. In fact, it's the exact opposite. It's the act of missing. Evolutionarily, we know that chickens and eggs each stem from the same origin and that, for this reason, neither could ever have come before the other. The universe merely did as it does until, from within a finite perspective, intentionally ignorant of its own infinity, a relationship became appreciable. Life and death gave rise to one another without ever having to start in a single moment. And so, it seems that we've all too soon crossed the borders of life and hit upon our next shoreline of understanding. But the question I see stretching out from here is, are we our bodies? After all, this was supposed to be the I that we identified as being alive at the beginning of our question how. The one who becomes aware of themselves when waking in the morning. The one who looks back at us in the mirror, who carries our head, eyes, and ideas around. One famous story related to this question is of Henrietta Lacks, who sadly passed away in 1951. In January of that year, Henny was admitted into Johns Hopkins Hospital with complaints of abdominal pain. At some time during her next several months of treatment, she was called in to have an X-ray. On this day, 2 samples of cancerous cells were taken from her cervix tissue. But upon removing the cells, cell biologist George Otto Gray discovered a curiosity, as it seemed that Henny's cells reproduced at a uniquely high rate, allowing them to be kept alive in the laboratory, proving extremely useful for ongoing medical studies. As a result, her cells were cultured and subsequently passed on to an enormous variety of academic communities, successfully facilitating countless life-saving studies worldwide, a practice that has continued to the present day. Since 1951, scientists have grown as much as 50 million metric tons of Henrietta's cells. And so I pose the question, is Henny immortal? Is she massive? Or are we just not the physical body? Firstly, it is all too widely known that just as the cells that made up your infant self are no longer a part of who you are today, neither will the cells of your current body be about when that much older version of you is enjoying your name. On average, it takes 7 to 15 years for the majority of our bodies to die, cell by cell, all the while being replaced by new cells. Our skeletons are replaced every 10 years, and our red blood cells are replaced every 4 to 6 months. Our skin is replaced over 2 to 4 weeks, and the cells in our stomach and intestines last a mere few days. But even though these versions of ourselves are gone both physically and mentally, we should notice that we don't mourn their loss as death. We instead consider the inheritance of their story as the continuation of life, which does seem to suggest that our idea of self is not one wholly retained within the physical matter. And if we look even closer towards the atomic scale of our bodies, and question the quantum body as a description of the self, well, then things really do become hazy, as our atoms haven't only been around for the majority of the universe's history, but they will continue to hang around for the rest of time. Inevitably, your precious star stuff will go back into the universe to live on for another day without you. Approximately 100 billion people have died across the history of our species. But when they did, their atoms continued. With 60% of their bodies being made of water, they mostly re-entered Earth's water cycle, continuing to support life in the process of plant photosynthesis and the production of oxygen. Equally, The carbohydrates left behind after death become nutrients that inevitably return to our diets. In fact, there isn't an atom in your body that hasn't once passed through the body of another person. So much so that there is approximately one atom in your body for every single breath that any human has ever taken. Every celebrity, every king, every moment in history, every achievement, every crucifixion, all of it literally exists in you. Within approximately 1 year from now, a tiny fraction of the breath that you just exhaled will exist within every human on this planet. Even your own descendants will one day take up your atoms, unwittingly converting the energy that was once you into the electrochemical reactions of their brains, enabling them to consider these very thoughts for themselves. Waves are not objects. Waves are just changes in the environment. And so it seems are we. A change that is entwined with the universe from start to end. And so, I find it a curiously comforting thought that, upon my death, a small count of radioactive atoms will be converted into helium atoms, light enough to escape the Earth's gravitational pull. And though some of these might find themselves merging with the Sun or Jupiter, it's considerably likely that the tiniest fraction of the body that I call mine shall continue to traverse the endless reaches of space, perhaps to roam freely until the very ends of time. Whatever that is.
Thank you so much for listening to the episode. I just wanted to offer a massive round of thanks and let you know that the YouTube page is currently up and running, and that's giving weekly visualizations to the same readings that's happening in the podcast. So if you want to go over there and check that out, that is, again, Infinite Now with Sean Crowley. So hopefully I'll see you there week by week. Apart from that, much love, and I hope you have a lovely day. See ya.